This is a warp spaceship that travels to Mars in 18 seconds. And this is its warp engine.
Engage.
That travels faster than light. But the problem is, nothing can travel faster than light. So how does this spaceship that only an advanced civilization can build work? And if the journey to Mars only takes 18 seconds, then where can other warp ships travel to in 1 day, 10 days, a month, a year? And how long does it take to reach the nearest black hole? Starting with the journey to Mars, there are 300 passengers on board this warp ship. The captain on the bridge issues the command to prepare for warp jump. And so begins the launch sequence. In 2 minutes, the spaceship will be ready to jump. Mars is far away. A traditional nuclear fusion spaceship full of passengers takes 3 to 4 months to reach the red planet. Einstein's special theory of relativity says that nothing can go faster than the speed of light. Traveling to Mars at light speed would take about 12 minutes and 26,000 years to reach the center of the galaxy. But a warp ship at warp 5 is traveling 40 times the speed of light and will reach Mars in 18.6 seconds. And to reach the center of the galaxy, it takes 208 years at warp 5 and 26 years at warp 10. How is that possible? The warp engine was built for one purpose: to transport humans into interstellar space, beyond the solar system. It is the interstellar engine. The solution to traveling faster than light is to stretch the fabric of space-time. And this is what a warp spaceship is designed to do. The captain's command is relayed to the warp field control on the spaceship. Stage 1. Here, the chief energy systems engineer and the exotic matter specialists activate the matter-antimatter reactor. This reactor creates the high energy levels needed to power and run the onboard particle accelerator that comes next. Matter-antimatter reactions are the most energy-dense reactions known in physics. When matter and antimatter collide, they annihilate each other, converting their mass into energy. Next, this powers up the particle accelerator. Stage 2. Inside the particle accelerator, which is the size of a room, particles are accelerated to near light speeds and collide. These collisions at high energies create exotic matter, matter that has properties of negative energy. Here is a quick explanation of what negative energy is and how it is used to make a spaceship travel faster than light at warp speed. Imagine placing a heavy ball in the center of a trampoline. This creates a curve in the trampoline's fabric, pulling it downwards. This represents how normal matter and positive energy curve spacetime, much like how the sun creates a curve in spacetime in our solar system. Now, the heavy ball is replaced with negative energy. This creates an upward curve on the trampoline's surface, as if pushing it from below, creating an area where space-time is expanded. Negative energy and exotic matter are forms of energy and matter that reverse and generate negative gravitational effects. A warp spaceship uses exotic matter and negative energy to create a bubble around it, squeezing the space in front and expanding the space behind, creating a wave-like effect that moves the bubble forward with the spaceship inside of it. The spaceship can surf over space at faster than light speed, but the spacecraft itself is not moving. Imagine a person standing on a flat escalator, an auto walk at an airport. Instead of walking, the movement of the conveyor belt shifts the person's position. Here, the person is the spaceship, and the conveyor belt is the warp bubble. The reason why the conveyor belt can move faster than light is because it does not just carry the person across a fixed path. It has the ability to stretch or shrink the path itself. The conveyor belt can shorten the distance in front and lengthen it behind, moving the spaceship to its destination quicker than if it were flying the whole distance. Just like a surfer who paddles versus a surfer who rides a wave. Back on board the spaceship to Mars, after generating exotic matter using the particle accelerator, the next step, stage 3, is collecting and stabilizing the matter in containment fields. Negative energy is then extracted from the exotic matter, so it can be manipulated and used to create the warp bubble. Stage 4. The negative energy is then transferred to the warp coils, which are inside the warp drive system. This area of the ship is run by the warp field chief engineer, responsible for managing and maintaining the warp field generators. The warp coils use the negative energy to create and maintain a warp bubble around the spaceship, squeezing the space in front of the spacecraft and expanding it behind. This is not a physical bubble made of a physical substance. The bubble is an area of space that has been warped and distorted. Once formed, the warp bubble is then stabilized, turning the spacecraft into a faster-than-light ship. Stage 5. The spacecraft's navigation computer system takes over, plotting and controlling the speed and path of the spaceship. The navigation is overseen by the astrogation officers, navigators of the solar system and interstellar space. But how does a warp ship steer, navigate, and stop? Steering the spacecraft, whether to go to Mars or to the nearest black hole, is done by changing the shape of the warp bubble to move in different directions. The warp coils can change the shape of the bubble by adjusting the distribution of negative energy around the spacecraft, increasing it on one side while reducing it on the other, making the spaceship bank and turn. The path to the destination needs to be clear of any celestial objects. A journey from Earth to Saturn takes 32 seconds, 1 hour to outside the solar system, and 12 days and 10 hours to Proxima Centauri b. How fast can a warp ship go? A warp spaceship can travel at different warp speeds. The coils adjust the amount of negative energy around the bubble to change the speed. Each higher level of warp speed requires more energy. What happens if the spaceship starts going too fast? It is still unknown what happens if more and more energy is used to go faster and faster, and what the destabilizing effects would be. So, warp speed limits are enforced. A journey from Earth to the white dwarf star Sirius B takes 25 days. It takes 3 years and 7 months to reach the dark cloud L1527 protostar, a young star that is still in the process of forming and gathering mass. And the journey to the Helix Nebula takes 5 years and 3 months. But expedition warp ships have taken journeys out to the nearest black hole, a place with extreme gravitational forces and hazardous environments. The closest black hole to Earth is Gaia BH1, 1,560 light-years away. It is a 3-year and 6-month journey at warp 8. The passengers do not experience any time dilation on the long journey. Time dilation is when time passes slower for the passengers on a fast-moving spaceship compared to people on Earth. If a normal, non-warp spaceship travels for 1 year at near the speed of light, on Earth 7 years will pass. But this does not happen on board a warp spaceship, because the spacecraft is not moving, but the space around it. So time on board the ship and on Earth move at the same rate. The warp spaceships are careful not to arrive too close to the black hole, Gaia BH1, as the strong gravitational pull of the black hole also creates time dilation, and the ships are careful to maintain a safe distance, making sure they don't get too close and are pulled beyond the event horizon, the point of no return. There have been mysterious cases and fatal anomalies throughout the history of warp travel. Theories predict that these warp ships exceeded the safe and known limits of warp speed. When one spaceship traveling for 25 days deactivated their warp bubble, the passengers found themselves not only in a different location in space, but also at a different point in time. 25 days should have passed outside the bubble, the same as inside. But instead, 32 years had passed. One theory as to why this happened suggests that the spaceship passed near one of the many undetectable micro-black holes hiding in the galaxy. Crew and passengers aboard another spaceship reported that parts of the spacecraft experienced time differently. A possibility is that the space-time was distorted unevenly, leading to localized time dilation. Then there was a spaceship launching on a Warp 9 journey that simply disappeared. Briefly, a cloud of gas was seen orbiting the location where the spacecraft had last been seen. One theory suggests that a malfunction in concentrating the energy to create the warp bubble led to the formation of a singularity, a miniature black hole. Back aboard the spaceship to Mars, the vessel is now ready to make the warp jump. The particle accelerator has created the exotic matter and negative energy. The warp coils have generated the warp bubble, and the navigation systems have shaped the bubble to target Mars.
Engage.
The spaceship is being carried by the distortion of space-time. As the space around the spaceship warps, traveling to Mars, systems and sensors monitor the status of the warp bubble and the negative energy, making instant adjustments as needed to ensure stable travel. The passengers on the spaceship feel no tidal forces. They do not feel the acceleration or sense the spacecraft turning during longer journeys. And looking out the windows, the passengers see that beyond the bubble, everything is distorted due to the bending of light. There are shifting patterns of stars and galaxies, and even multiple images of the same object. Only seconds have passed, but the spaceship is reaching its destination. It is now time to stop. The stages are reversed. The warp coils scale down, emitting less negative energy, and the warp bubble is slowly collapsed. The spaceship has dropped out of warp, and the passengers are now 35 minutes away from Mars. This is the safe zone, because warping too close to Mars would disrupt the space around the red planet. The spaceship now transitions to sublight travel, switching over to its nuclear fusion engine, traveling the rest of the way to Mars and entering the planet's orbit. The passengers have completed their short journey, arriving at the red colony. But out in interstellar space beyond the solar system, a team of scientists is hard at work, pushing the limits of warp bubbles and space-time distortion even further, aiming to create conditions for the formation of man-made artificial wormholes. A story for another time. The first volume of the Encyclopedia of the Future is available on Patreon.